Hello everybody and welcome back for more of the 2005 Fermat paper. We're up to question number 12, so hopefully you've given that a shot and we can get ready to take a look at it together. So question 12, starting with the 2 in the center, the number 2005 can be formed by moving from circle to circle only if the two circles are touching. How many different paths can be followed to form 2005? So we got a 2, then we got some zeros, and then we got some 5s. Okay, so it's the zeros in the middle that are going to be a little tricky for us because we're going to have to move from zeros to zeros. What I'm going to do is I'm going to count the different ways I can get to different parts of the 2005 in stages. So we're going to grab our notepad here. So how can I get a 2? Because I need to make 2005, I need a 2. Well, there's only one way to get a 2, and that's the 2 right in the middle. So there's one way to get here. And then I need a 0. How many ways are there to get to a 0? I'll need a little more space left. But how many ways are there to get to a 0? Well, we're on the center, and then surrounding the center are 6 circles, each of them containing a 0. So if I want to go from a 2 to a 0, I've got to go through touching circles. So there's one way to go from this one path to this one path. Another way to go here. So there's one way to get each of these circles, each of these zeros, to be the second 0. Now, as I say, the third 0 is the trickiest. So now, suppose I wanted to get to one of the zeros. Now the whole thing is symmetric, so let's just consider this the blue circle. How can I get the 0 in here to be my third digit, my second 0? Well, I would have to approach it from one of the other zeros, right? So I could approach it from this 0, and I could approach it from this 0. So how many ways are there to get to the blue 0? Well, there was one way to get to this 0. So to then go to the blue 0 is one way. And there was one way to get to this 0 up here. And he's only got one path to go into the blue 0. So 1 plus 1, there's 2 ways to get to the blue space from zeros. And that means we're going to have 2 ways to get to everything as our second 0. So now we ask ourselves, how can we get to the 5s? So the 5s are a little further out. Okay. So we're sort of building hexagons as we go, and I admit this isn't the best picture. But we're sitting at, say, something like one of the zeros, and we want to get to one of the 5s. So suppose we're sitting here at this 0. Okay. What 5s could we get to? Well, we can get to 3 of these 5s. Actually, no, I think the easiest thing to do is say, how can I get to a 5 rather than where can I go from the 0? It would be more in line with what I've been talking about. So there's sort of 2 different types of 5s. There's a 5 out here who's sort of on the side of this hexagon. And then in green we'll say there's sort of these 5s in the corners. So how can I get to a corner 5? Well, I can only get to him from this red 0. How many ways were there for me to get to that 0, have that 0 be the third digit? 2. And that means there's 2 ways to get to this corner 5. And then 2 ways to get to this corner 5. So there's 2 ways to get into the corners. Now how about the orange side 5s? Well, I can approach them from either the blue circle or the dark blue circle. Now there's 2 ways to get to both of those zeros as our third digit. And so just like before, the 1 and the 1 combine to make a 2, the 2 2s combine to make a 4. So there's 4 ways to get to each of the side 5s. And once we've hit one of the side 5s, we're done. We've made 2005. And we've done this in a very logical, very precise manner where we count the paths to get to and from places. Okay? So once we hit a 5, we're done. We just need to count up how many ways can we get to 5s. Well, there's 2 ways to get to each of the corner 5s, so there's 6 corner 5s. And there's 6 side 5s, 4 ways to get to each of them. So 6 times 2 plus 6 times 4, 12 plus 24. Or you can factor out the 6 and do 6 times 2 plus 4. Either way, we get 36. So 36 is the number of different paths, and that's A. Okay. So, in the next video, we're going to take a look at question number 13. It has a regular hexagon, but we'll see that next time.